Okay, so we kind of laid the foundation for the least squares regression line in the last video. Make sure you know this definition, please. So let's revisit the track and field data that we talked about a couple times before. So this is the 40-yard sprint times and long jump distances for some stat kids or something. So let's find the least squares regression line. You guys really know how to do this. I think you've done this in several different classes before. And we had to do it when we calculated the correlation coefficient earlier. So to do this, let's open up a scatter plot, which is good. I think there's actually a way to do the regression. Well, I know there's a way to do the regression line without looking at the scatter plot, but you know, to be honest, you should never run a regression without looking at the scatter plot. So let's just run it from the scatter plot. So sprint on the x-axis, I'm going too fast here, and jump on the y. So look at it. Does it look like a linear model is appropriate? Yes. Okay, so now it makes sense to find the least squares regression line. Keystrokes are menu, analyze, regression, and let's pick the a plus bx model. So there's my equation. Y equals 4.404, whatever. You can kind of see it right there. Now, if you write this down for this next answer, you're going to get it wrong. You're going to get it wrong for two reasons. First of all, you don't have a hat on the y. So that's an actual, not a predicted. So we got to put the hat on. And then also there is no x or y in the problem. There's sprints and jumps. So if you wanted to use x and y and then call x equal this, like define your variables off to the side, you could do that. But you would have to do this step. I prefer to kind of just change the x and y's to variables that make sense in this problem. So here's my regression model. Jump hat, predicted jumps are 414.8 minus 45.74? 74x. 74, but the x was sprint. So if you write this down, you don't have to define the variables. You have this predicted. So this is good for just an answer. That's all you need to put down. But if you put x's and y's, you're going to lose points. If you don't put the hat, you're going to lose points. Interpret the slope. So what is the slope? This is the slope. Remember, slope is change in y over change in x. So my change in y over change of x is negative 45.74 over 1. My y's were long jump distance, so that's in inches. My x's were sprint times in seconds. So what does this mean? Negative 45 inches per 1 second. Basically, if I add 1 second to my sprint time, and by the way, if you add a second to your sprint time, that means you're running slower. Your predicted jump height is going to be reduced by 45 inches. That's it. If we increase sprint time, that sounds funny. I'm sorry. If a person's sprint time increases by 1 second, their predicted jump distance will decrease Why decrease? Because it's negative by 45.74 inches. Okay? Kind of the key word that you got to watch out for on this one is predicted. The actual jump distance does not necessarily change by 45, but the predicted will change by exactly 45.74. Okay? Interpret the y-intercept. Remember, y-intercepts are when x is equal to 0. When x is equal to 0, what is your y value? That's what the y-intercept is. So in this case, though, x represents the sprint time. So basically, if somebody has a sprint time of 0, So if they can run the 40-yard dash in 0 seconds, then their jump height would be 414. Doesn't make sense in this problem. You can't run 40 yards in 0 seconds, but if you could, when someone's sprint time is 0 seconds, their predicted jump distance is 414.8 inches. Again, doesn't really make sense in this case. Sometimes it makes sense though. Sometimes it's a little more sensible, but that's what it means. Find the long jump distance prediction based on a linear model for the person whose sprint time is 6.73 seconds. So basically I want to use my model to make a prediction on jump based off of a sprint time. So just plug it in. On the AP test, again, you have to show your work. You don't actually have to write that, but you do have to write 414.8 minus 45.74 times 6.73. If you do not put this down, you will not get credit for the problem, guaranteed. And the thing is I'm not actually going to type that in my calculator. As you know, when you run this model, it's going to store that regression equation into your document. So if you hit the vars key, there's my R value. Right there is my f of x. There's my function stat regression equation. So if you select that, and then function notation, if you just put an x in, there's my model. So if I want to evaluate that thing at 6.73? 6.73, just put it into the function notation, 106.9. Or, you don't need to do that, but, if you want to, 106.9 inches. Now, some of you guys love writing these full sentence answers. The predicted jump time for a person whose sprint time is 6.73 seconds is 106.9 inches. But to be honest, this is all you need. I want this, and I want this, and I want units. Find and interpret the residual for the person with a sprint time of 6.73. All right, so residual is y actual minus y predicted. Remember, AP class. So the actual time, so what was the actual time? To find the actual time, we got to go back to our original data set here. 6.73 seconds. That's that person right there. So he or she, I should say, there's no more, is there? There's just one. Their actual jump distance was 78. That was their actual. Their predicted is 106.9. So what's the residual? 78 minus last answer, negative 28.9. And my units are going to be in inches. Now, oftentimes they ask you to interpret this value. I did ask, I'm sorry. So interpret this value. Well, that means my predicted was bigger than my actual. So for this kid, you could either say the actual was 28 less than the predicted, or you could say the predicted was 28.9 inches more. I like to say the predicted. The prediction was an overestimate. Could say overestimate, or I could say the prediction was 28.9 inches greater than the actual jump distance for this kid. For this kid, the prediction Sorry, the predicted, I'm sorry guys, the predicted long jump distance was 28.9 inches greater than the actual jump distance. Something along those lines. Kind of key word here is that you gotta give a direction to it. That's interpreting that negative. With this regression line, just to show you something, this is kind of neat. Remember I said whenever you run the model, it does several things in the background. So let's take a look at that vars menu again. That's the coefficient, that's my a, that's the y-intercept. There's my slope. There's my r, we'll talk about that later. There's the function. If you look right here, stat residual. Let's see what that is. A bunch of values here. But what was our residual here? First of all, which data point was it? It was the 1, 2, 3, 4. It was the 5th data point over, and the residual was negative 28.9. So if we go 5 data points over, 1, 2, 3, 4, 5, right there it is. When you run the regression model, it actually calculates the residual for every single data point and stores it in your calculator. So you can access it that way if you want to. Would this regression line be more useful for predicting long jump time of a student that runs the 40 in 6 seconds or one that runs it in 9 seconds? Why? Well, my data values range from about 5 to about 7.5. So 6 seconds, because 6 seconds is within the sprint times of my data set, of the data set, whatever. 9 seconds is not within the data set. You don't have to use extrapolation. You know what I think what some kids will do on a question like this is they'll say, yes, or 6 seconds because extrapolation, because 9 seconds is extrapolation. You won't get credit for that. What does that even mean? 9 seconds is extrapolation. They don't want you to flaunt fancy vocabulary. They want you to explain things. 6 seconds. Why is 6 seconds good? Because it's within the data set. Why is 9 seconds not? Because it's not within the data set. Suppose we use this regression line to estimate the long jump distance of a 13th student that ran the 40 in 6 seconds, and the residual of this kid was negative 6 inches. Find the actual long jump. Well, residual equals y actual minus y predicted. I know the residual. The residual is negative 6. The y actual, the student ran the 40 in 6 seconds. Find the actual. So I don't know the y actual, sorry. So the y actual is unknown. Can I find the y predicted? Yeah. If you want to predict it for 6 seconds, just plug it into the equation. Find the prediction. 6 seconds, 140.3. Solve this for the y actual. Add 140.3 to both sides. So I want to go 143.3 minus 6. This is positive 1. I'm sorry, what was that again? 134.3. 134.3 inches equals your y actual. Find the actual long jump distance. No sentence required. What is required? Set up the equation. Set up the equation. Solve the equation. Okay? Thank you.